Dividing decimals, page. Huh? You didn't have a question? I know, I asked you that. I said you have a question. What was your question? Can we make it quick so we can start? Is this something we can answer in like a minute, or is this something later? You can ask later. Okay. Dividing decimals. Page 43. $30 divided by 6. We don't necessarily need to set one up like this because we should be aware of what we're working with here. But if we did, we'd write it exactly the way it looks. The 30 is going to be divided by the 6. How many equal groups of 6 can we make out of 30? And therefore, it's 5. Now, the lesson for today is dividing decimals. Did we, in this case, divide with any decimals? No, yes, we did. We did. Whether we knew it or not, we did. Where's the decimal here in 30, DeKayla? Right here, okay? Which means that decimal gets carried straight up as long as the number on the outside is what? No. 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 Right, as long as this number on the outside is a whole number, whatever's on the inside, I just carry straight up, okay? That being said, 6 goes into 30, 5 equal times, and we're all set. And we've moved past, way past the idea that you couldn't have a larger number on the outside and a smaller number on the inside, okay? Because we no longer deal with those things called remainders. We use decimals to show any values less than one whole, okay? 9 and 12/100ths divided by 6, okay? So we'll go through, we'll set it up. What you're dividing by, in this case, if you read it out loud in your head and you say 9 and 12/100ths divided by 6, the 6 always goes on the outside. What you divide by always goes on the outside. And we're going to put in our 9 and 12/100ths. After we get it set up, we're going to take a look at the number on the outside. We're going to take a look at what we're dividing by. And is this a whole number or not? It is a whole number. Therefore, I'm going to take the decimal. I'm going to put it right up top. Just carry it straight up there. Now, all the division will take care of what place values we need to put everything in. See, with multiplication, we take care of the decimal last. But division is the opposite of multiplication, so we take care of the decimal first, okay? Does 6 go into 9? One time. So 1/6 looks like that. Subtract, 9 minus 6 is 3. It's not supposed to go into this 3. Because when I decide how many times the 6 goes into it, I should take it as many times as it goes. So because it doesn't go into the 3 doesn't mean I start getting 0 happy and start putting zeros in there. Okay? Now I'm going to drop the 1. The 6 go into 31. Yeah, 5 times. So that 5 goes over the 1 I just dropped. And then subtract. Now I'll drop the 2. 6 going to 12. 2 times. And once I've taken it to 0, the final answer is 1 52/100ths. Okay? Dividing the decimal part with those really isn't all that different than just regular division. Because once you put the decimal where it needs to go, the division takes care of the rest. Yeah.
What if, like, 6 is a double number?
A double one? A 2-digit number? As long as it's whole, we're fine. Like, okay. Now here is one of those cases where you'd say, oh, our larger number's on the outside. We can't divide it. Well, that's not true. In fact, 12 will go into 1. It'll go into 1 in 728 thousandths. It just won't go in one whole time. But part of 12 can go into 1. Okay, and that's what we're going to find out. So double check, Frank. Make sure that this number on the outside is a whole number. In other words, is my decimal all the way to the right? Good to go. So now I can just transfer up. Does 12 go into 1? Can I fit 12 into 1? No. That's where I'm going to put my 0. Now I shift my focus over. Does 12... We don't even look at this as 1.7. The decimal's taken care of. It's up here. This is now 17. Does it go into 17? Once. So now that 1 goes over the 7. 5, drop the 2. How many times does 12 go into 52? 4. And how many times does it go into 48? Because I'm going to drop this. It's going to be 4. And there we go. Okay. It's very important that you keep everything lined up. If things don't stay lined up, you run the risk of having some issues. Okay. Now, it doesn't appear that for today we're going to run into situations of decimals on the out. Yeah, we will. That's all right. No big deal. Let's try one of those. Okay. All right, so what's glaringly different about this one is the fact that the number on the outside is a 0.4. A 0.4 is different than just a regular whole number 4. So I know that anytime I have the decimal after a number, that makes it whole. How many places am I going to have to move this decimal here to make it a whole number? 1. I'm going to move this once, and I'm going to put the decimal there to make that a 4. If I move it once on the outside, I have to move it just once on the inside. Okay? Okay, now whatever, I'm going to put a 0 there just in case. However many places I move it on the outside is how many places I move it on the inside. The number on the inside doesn't have to be a whole number, as we found out before. Was this a whole number without a decimal attached to it? And we were still able to divide it just fine. What's important is that this one is. Now we're working with just a 4. 4 goes into 29. 7 times is 28. Subtract 9 minus 8 is 1. Bring down the 5. 4 into 15. 3. Right? Into 30. Another 7. So another 28. Got to add another 0. Whoops. Yeah. 2. Then my 0 here, and then 5. That'll bring us to 0. 73 and 75 hundredths. How many zeros am I allowed to add to the end of the number on the inside if I need to? However many as I need. Until I take it to completion. Yes, ma'am. If I didn't have to move anything. No. Well, I suppose, yeah. But that's where it just gets really confusing when you start working with it. That's why you just want to work with a whole number. Okay? That's why you just want to work with the whole number. Let's try one. There you go. Peek here. All right, is the number on the outside, what I'm dividing by, is it a whole number? No. How many places do I move my decimal to get a whole number? 1. So if I move it 1 on the outside, how many on the inside? 1, just 1. And you say, wait a second, that's not going to take me to the end. It doesn't have to. Okay, I just have to be fair. I just have to do what I do on the inside to what I did on the outside. Now I'm working with what number on the outside? Not 3.1 anymore, but what? 31, because I moved the decimal. Does 31 go into 1? Does it go into 10? How about 102? Yeah. Now we'd say what? If you'd estimate how many times does 30 go into 100, you'd say 3. And if you don't know what that is for sure, then just find out. 31 times 3 is 93. So we will subtract from the 102, and we should get 9. 31 into 96. Well, if times 3 is 93, does that fit into 96? Yeah, so go right over that 6, 93, 3 left, drop the 1, and 1. 3 and 31 hundredths. Remember, you got it. I think it'd be a little bit better now that you've had a chance to see one. Good. Let's take a look. 1027 already. Eli, number on the outside, a whole number. What's going to get us there?
Put the decimal behind it.
And how many places is that? 2. So 2 places on the outside means 2 places on the inside. Okay? Now, I'm not working with 0.96 anymore. I'm working with 96, which is really close to what number? All right, so when I'm going to keep that in mind when I'm trying to figure out how many times this is going to go into something else. So does 96 go into 14? No. So I'm going to make sure that over that 0 and the 14, I put the 0 over the 4 and the 14. Okay? I'm saying that that 96 does not go into 14. So when you do this, and that's where I'm going to say you want to make sure that you spread out, because you may have meant that, but if you have that down, and just things get out of order. That's why sometimes people use like graph paper for it. Okay, so they keep everything in line order. Anyway, 96 into 144. Well, 100 is going to go into 144 how many times? Once. So, but we're going to call it 96 because that's what it is. 14 minus 6, 8, and 48. Okay? Now, remember, it's not supposed to go into this. Now, if we drop a 0 and it still doesn't go into this, then we put the 0 up top. So how many times does 96 go into 480? 5 times. And 480. Okay. Well, that's what makes division somewhat challenging, because if you make one small mistake, whether it be in the subtraction or the multiplication, you can end up kind of going on forever. Okay, Carlos? Yeah, and that's what I said here. Like, you probably got with the 48, but remember, it's not supposed to go into that. You're supposed to take this as close as you can, and you did. This couldn't have gone in 2 times. You couldn't have put 96 into 144 twice. Now, like I said, if you drop this 0 and you make it something that, okay, I dropped the 0 and it still won't go into it, then you put the 0. But that's just, I think we get so used to having to do that. Let's take a look at our sheet for 1-9. And we're going to have to kind of take this in parts because we didn't get to terminating or repeating. So for now, we'll do numbers 8 through 11. And the common theme with 8, 9, 10, and 11 is that in each case, you're dividing by whole numbers. You will not need to move any decimals around. Where the decimal is where you're just going to put it straight up. However, 23, 24, 25, 26, those are all going to be required. You need to move the decimal on the outside, henceforth moving it on the inside. So it's only 8 problems. You've got about 10 minutes right now. Okay. And you may begin. I will answer any questions you have. If you want to bring your stuff back, that's fine. Keep in mind, as people come back to me with questions, I can hear you.